So of course, you can take a look at those graphs and see if you can tell right away if any HA and VA or potentially some slant asymptotes, right, could help you to figure out which option might be right. Then go back and see if you're supposed to have them based on the functional form. So now, first off, we see that there is a zero, right, at x. Oh, sorry, my bad. It keeps pole. There's a pole, right, at x to the 3. But can you guys tell me, is that an even or odd pole? Even, power 2, right? So even pole means that it will be a VA associated with that pole, and the graph, when it approach that VA, it's gonna go either, right, to positive infinity, right, or both going to the negative infinity, right? That's a even pole. So I think that now you should be looking at either A or D. Right? Does it make sense? Now, if you want to remember the even pole and odd pole, think about, I'll put some side note, 1 over x and 1 over x squared. So the graph of 1 over x looks like that. Do you see that? It has a pole at the origin, right? So the y-axis is a VA. So the graph goes one way and the other, right, on either side of the pole. But for a 1 over x squared, it does have a VA at the same location. So the graph approach in the same direction. Okay. Now, we're looking at A and D. Do you notice the big difference between these two? The two dashed lines, right? And the first guy has a horizontal asymptote at probably 1. And this guy has -1. Now, how do we find the horizontal asymptote? I think that we just did that question right at the end of last class. Which case it is? Does this function has no HA or an HA, which is the ratio of the leading coefficient, or an HA which is as simple as y equal to 0? And how do we tell which case that is? Anyone remember? Okay, so that's probably one way to see it. Or I prefer that you remind yourself that the degree of the numerator and the degree of the denominator are the same, right? And therefore that falls into one of the cases that we talked about. So it has a constant VA, a non-zero constant VA, since the leading coefficient of the numerator is 1. The leading coefficient of the denominator is also 1. Right? Even though you're going to square it, but still 1 squared still 1. So therefore, there should be a HA at 1. Okay, so you're going to go with letter A. Of course, why would you bother to do something like that if you could have just graphed it? Right? Let me just quickly type it up. So let me do a fraction. So x squared plus 2x over x minus 3 squared. Right, so x minus 3 squared, right? Then square it. Okay, so I got that. Hit enter, right? Let's go ahead and hit the graph. So is that good enough for you to pick? Right, obviously, right? So now don't feel like that I have, different ways, and I want to do, all of them, right? To just to be cautious. So I do have to be open to those different ways as an instructor. But now for the final, you find whatever method that works out the best, right? Or the one that you're most comfortable with. Okay. All right. So now please stop me, if you do need any more clarification. But I'm gonna move on to 25. Now for 25, please make sure that you do take a look at the packet I gave you for 8.3. So there are 4 rules, right? They're targeting either the linear factor, like x plus 6, right? Whether it's been repeated or not, and quadratic factor, right? With or without repeating, and things could be mixed, just like in this case. Therefore, you shouldn't really have any issues with a question like that. I think that the answer should be letter D. There we go. But I think that people might pick letter B, if I remember correctly from our prior test. You see, the problem with the letter B is the numerator of a quadratic non-factorable denominator should be at least a linear factor. Okay. It's like you have to be open to the worst case scenario, right? Don't always assume that it's going to be as simple as a constant. So the rule is either the original fraction or those partial fractions, right, must be in a form that the numerator has to be at least 1 degree lower than the denominator. And therefore, see that degree 1 for the numerator, right, and degree 5, right, on the denominator. Every single partial fraction. But I know that you say that, well, what's wrong with the constant if the degree of the numerator has to be lower, and it is lower, right? But like I said, if you have to find out the worst case scenario, you have to be open to the worst case scenario, which means that the numerator could be as high as degree 1. So make sure that the rule number 3 and 4. All right, so again, assuming that you guys are fine with that, so I'll move on to this question, which is, technically speaking, more practical. If you just want to use the partial fraction decomposition for whatever reason. And also in a test, so unless you have the time, probably 3-4 minutes, I think that you might do, have that much time to spend on a question like that in a final. But I still suggest, maybe go through the standard way once, right? Just to remind yourself, the routine things. But I think that for 27, the best way to do it is to just, substitute some easy numbers, right, for x. So let's say if you have to take the x to be, an easy number, what will be the number that you feel like taking for this problem? What do you want the x to be? 0. Make it 0, right? And you see that the easiest number you can ever find, but of course, it shouldn't really cause any problem, right? But you will know if it causes a problem, right, once you plug it in. If you take x to be 0, so you have nothing on the top except for -2, right? On the bottom, the x are gone. You have 2 times 1 squared, right? So it'll be -1. Well, now you're gonna do the same thing, right? By setting all the x's on those options to 0 and evaluate all of them, right? So let's try maybe one of them just to have an idea. So this guy's gonna be -2 over 2 plus -4 over 1 plus 4 over 1, right? So this is -1, this is -4, and oh, that works. Oh, let's see, 27. Yeah, it's indeed A. But sometimes I do want to make sure that hey, could it be some happy coincidence, right? So maybe try a few more options. If you're that lucky that the first option already worked out, that means it probably took you only 15-20 seconds, right? So you could spend another 20 seconds just to check a few more, right? But anyway, so hope that you guys get the gist of this technique. Okay. All right. So again, you can certainly find more information about the right way of doing. I mean, not the right. The standard way of doing a partial fraction by going back to the 8.3 recording, or find out a packet, and there's some types of examples. All right, so now let's take a look at the questions from the chapter 9, which are matrices. So we have the system of 3 linear equations and 3 variables. And I want to use the Gaussian elimination and back substitution to find out the solution. So I hope that you realize for some other questions, like even a partial fraction, they're still doable unless you have those quadratic or repeated denominator. But matrices, it's not very realistic, right? Even though we do want you guys to be able to do it, but it will take time. Okay, so it looks like a multiple choices, but if you do it a standard way, it will be no better than a FRQ. So the best way to do it is type up the matrix in the TID4, right? So since we haven't done it for a while, all right, so let me do that to have it recorded. So then, if you want, you can follow the procedure and try it thoroughly, when you get a chance. All right, so I'm gonna go to where's the matrix? Oh, it's been a while. Okay, here, right? Second matrix, right? I'm gonna go to edit, and let's say I'm gonna call the augmented matrix matrix A, and it needs how many rows? 3 rows, right? 1 row for each equation and 4 columns, right? The first 3 columns are for the x, y, z, and the last column will be the constants. All right, so let's do a 3 by 4. All right, so I'm going to type in now. So you tell me if I make any mistakes. Right? Also, you can check if I did type up, the things that you're expecting. So 1, -1, 4, right? -7. Now, if you saw me doing the 0 minus, because I don't have a separate key on the keyboard to do the negative. I don't want to go down and keep hitting the negative. But you should use the negative instead of the minus, right? For a negative number. Be careful with the second row. The first entry should be 3, right? The second entry is 0, since the y is missing. Third entry is 1, and the last entry is -2. All right, so then I have 1, 4, 1, and -6. Oops. See what I did? Hopefully it saved my work. It did. Okay. So I didn't type in 0 minus. That's why it complained. So, but you do the -6. All right. So 0 minus 6. There we go. So 1, -1, 4, -7, 3, 0, 1, -2, 1, 4, 1, -6, right? Okay, so let's say quit. So we need either the row echelon form or reduced row echelon form. Now, if you want to do the Gaussian elimination, then you do need the row echelon form, right? Then you're gonna have to do, a few more steps, right, to do back-substitution, right? But I mean, if you're solving for the solution, I think that the reduced row echelon form will be still, better. So what you can do is now go to again matrix, right? Then go to math and scroll down and find the reduced row echelon form, RREF, reduced row echelon form. Hit it, right? So then it's asking for, hey, what matrix you want to get the reduced row echelon form? Again, second matrix, right? So you can call the first matrix, right? And hit enter. So it tells you the reduced echelon form, which you can literally just read off the solution from the last column, right? So with 0, -1, -2, so that has to be A. Okay. Now, nothing crazy here, just, use the technology with your math knowledge. It should work out, seamlessly. But again, talk to me if you do have an issue with the calculator. Otherwise, just follow, the recording if you want and try 30. Anyway, now moving on to these two questions, 31, 33. I mean, almost the same, right? But notice that the instructions I suggest something. That means, in the test or final, you might want to read the instruction real quick to understand sometimes, things might not work out always the way you want. So these two questions says that it's possible that you get no solution, or as you can tell from the options in 33, infinite solutions, right? Since the variable z is a free variable, and the reason why we call it free is that it doesn't have a definite answer, right? So you can take z to be whatever real numbers you want. But when it comes to solving for system equations, it's the same thing. So you just type up the matrix, call the reduced row echelon form, and go from there. So let me type up 33 because you see that 33 already hinted from the options. It has infinite solutions. So I'll type it up and show you what it looks like. I mean the row echelon form. Then we'll go back, to the question in 31, right? Even using the same matrix, because all that matters is the structure of the row echelon form. All right, so let's go ahead and type up another matrix. Let's see, second matrix. So just to save that for my PM class, let me do the matrix B. All right, so I need, again, 3 by 4. So again, check the entries. All right, so oops. 1, 1, 1, 9. 2, -3, 4, and a 7. 1, -4, 3, -2. All right, 1, 9. Okay, good. So let's do the reduced row echelon form. Okay. Now, you say, wait a second, those are all fractions, right? Now, if you want, you could keep them as decimals and work with them. Then later on, turn things into fractions in the calculator. Or if you don't want to see them, then you can turn those fractions into those decimals into fractions. So just hit math, and the first option is going to turn everything to fractions if it's possible, or going back to the decimal form. All right. Now, what you see here is a 0 row. All right. So everything in that row is 0. So that should alert you, right? You have two possibilities for something that's special, either infinite solution or no solution, right? But in this case, you can tell, since I was using the 33, all zeros means no solution. My bad, infinite solutions. And the reason is somehow by doing those kind of matrix algebra, we realized that there was one equation that's redundant. Otherwise, why don't think that it's missing a row, right? That means effectively only two equations are independent. But now you have three variables, right? But you're only given two equations. It's like asking to find out, let's say 10. How do I put it? So I wanted to work on 10 assignments, but all I did is just a couple lessons, which didn't even cover all the topics. So you weren't given enough information to work out those things, just like we have three variables, but only two equations, right, to tell you how they're related. So infinite solutions, right? So now, if I were to change the last row into 0, 0, 0, -2, and that doesn't have to be negative, could be anything, but the last number is not 0. That means you have a contradiction. The way to see that is for any row that looks like a whole bunch of a 0, and all of a sudden you have something non-zero. If you were to translate that row into an equation, it reads 0 equals -2, right? Because those zeros are the coefficient of x, y, z. But that's obviously not going to work, right? So that means you have contradiction. So would you say that if you were to type up the matrix in 31, you should expect a row at the very bottom that has all the zeros except for the last entry, right? And I believe that 31 is A, okay? But I'll have you guys to do that if you want later. But now I still have to deal with 33 because which option should we pick? So now let's write it out. So we have I go with the fractional form. The first equation reads x. You know what? Just to be safe, 1/0.7 34 over 5. 0, 1, -2/5, 11 over 5, 0, 0, 0, 0. Right. So that's the RREF. So we translate that into equations. X plus 7/5 z, remember that this y term is missing, equals 34 over 5. And then you have y minus 2/5 z equals 11 over 5, right? And that's all. So what you do is solving for the x and y, right? Because there's nothing you have to do about a z, just leave it as is. I think that you can see right away that x must be -7/5 z plus 34 over 5, and y has to be 2/5 z plus 11 over 5, right? So does it match anything? I think it's just letter A, right? 33 is indeed A. Yeah. All right. So any questions about a problem like that? So now you see when it comes to solving system equations using matrix, it could be as easy as 29. Type up the matrix, call on the reduced row echelon form, read out the solution, right, from the last column. Or, you know, if they did hint in the instruction, there might be no solution or infinite solution. You can even tell from the options if there's an empty set symbol, like in the letter A for 31, or all the option has a free variable, right? Could be Z, could be T, could be something else. So take a close look at the reduced row echelon form. And 33, you do have to do, you know, unfortunately, the back-substitution to get whichever option you want to pick. All right. Cool. Let's move on. Go ahead. Now, the book answer is the Gaussian elimination require only the row echelon form with the back substitution. Okay, but by doing a few more rounds of the row operation to get to the reduced row echelon form, and it's easier, and we decided to call it Gauss-Jordan elimination. So there's another guy, you know, figured that just do a few more steps. But practically speaking, the reduced row echelon form, if you ever get it, right, will be better. It's just like, you know, would you still bother to, I mean, later on, you know, when you get to my age, if you have to do something, not necessarily teaching, right? If you have to check your kid's homework, you know, when he or she is learning the quadratic equations, would you still do it by hand, or you just maybe nowadays use the AI to scan the work and see, hey, you know, do you see any errors, right? Or, you know what, if I have to work out some problem which the numbers are kind of ugly, but when the little kids are taught, you know, in the first, you know, the first time they learn the quadratic function or equations, they know how to deal with those fractions and stuff, right? I don't want to do that. I just put in the quadratic formula because I know that it works out no matter what. So reduced row echelon form is more practical. Yeah, even though that it says Gaussian elimination. All right. Now moving on. Now, when I pull questions from the question bank, oh, by the way, so guys, you know, feel free to take a break, you know, but come back as soon as you can. I'll keep going through the problems, you know, because things is recorded, and I do want to get to the end of the packet, right? And I'll let you go at 11:40, right? Anyway, so yeah, just, you know, if you want to take a break, you know, quietly leave the room and come back. So for question 35, the reason why I pulled that question is because I do notice from was the second test? No, the first test, right? The first test about sequence and matrix. Somehow people either didn't figure out the correct algebra they have to do for the X, which is a matrix, and somehow later they, you know, mess up the calculation. So first off, what you need to do is solve this equation like algebraically, as if the X, A, and B are just regular numbers. So what you do is isolate the X. I think that probably, you know, people is going to be thinking subtracting the B, right? So you're looking at negative X equals, you know, 3A minus B. But you still have a -1, right? So I'll say that either divide, right, -1 or multiply by -1. But later on, since you're going to be dealing with matrices, division is actually kind of awkward. So we do have a multiplication defined for the matrix. So I'll multiply both sides. With -1, okay? So it reads X equals negative 3A 3a minus b. Or if you feel like distributing a negative sign, you could negative 3a plus b, right? Either way. So that should be what x is supposed to be, either algebraically or, matrix-wise. So now if you want, you can do the matrix scalar multiplication by hand, just by multiplying every single entry in the A by negative 3, then add it to the B, and I'm sure that you can do that. Or, you can type up the A and the B and do the multiplication the way I showed you. So it will work, okay? Now, I'm kind of lazy. I don't want to type up the A and B anymore. What I can show you is, you guys remember that I had two matrices already typed up, right? So, but they're 4 by 3. Do you think I can still do addition, subtractions between A and B? Basically, are they addable or are they subtractable if they have the same number of rows and columns? And the answer is yes, right? And the reason why I'm asking you is you might have to think, are matrices compatible when it comes to multiplication? And they might not, even if they have the same rows, numbers, rows, and columns. So now let's say if we had A and a B specified like in a calculator instead of the 3 by 2 matrix. So let me type up negative 3a plus b, or I can even go with the first row to show you, how that works out. So I do negative, open parentheses, right? So 3a, 3 times matrix A. So I'm going to call on matrix A, right? Second matrix, so matrix A, right? Then I'll add matrix B, second matrix 2. Here we go, right? Close parentheses, hit enter. So that's what the X as a matrix is supposed to be. Okay. So now, in the final, is it worth it to type out the matrix and do that? So then you guarantee to get it right, or you feel like that, you know what, I trust myself a little bit more. So then, do the math, by hand. So at least that for 35, I think that either way, typing things up, if you tend to mess up the negative signs and getting errors and go back and fix things, it's probably not worth the time. Okay. Anyway, but you figure it out, right? And that's exactly what you also have to work out before the final, not just the math. It's how you're going to be taking the test and make sure that you prevent yourself from making the same kind of mistakes that you did back in the test. Okay, so multiplication. So now for multiplication, and I do encourage you guys to type up the matrix and do it in a calculator. Right? But I do want you to notice that it's possible that they have an option saying that A and B do not multiply, right? It's not compatible, or they say AB is not defined. So the way it works is, let's say if a matrix A is n m by n, so m rows and columns, right? And at times a matrix B, which is n rows, p columns, and they do multiply. All right, so this is fine. So you can do that. And just so you know, the inner, right, indices, inner, I mean the number of columns of the first guy on the left and the number of rows of the second guy on the right has to match. And once you do the multiplication, you're going to get a new matrix, right? Let's call it C. And the C is going to have the number of rows of the first guy, number of the columns of the second guy. So basically, the outer index survive. The inner one got eliminated or annihilated, right, however you put it. Okay. So yeah. Now, what about the two matrix I typed up in the calculator? So let's say if I do oh, you know what? Matrix A times matrix B. Oh, matrix A, second matrix A, okay, times second matrix B. Huh? Oh, I thought that I typed in something wrong. I didn't even read. Do you see what it says? Dimension mismatch. And that's exactly what I want to show you. It means that the calculator complains. It doesn't work, right? A times B is not defined, right? Well, not in this case. But what's wrong with that? Let me show you the matrix A and a B. So A is 3 by 4. B is also 3 by 4. Do they multiply? According to our rule for multiplication of a matrix. Do they multiply by having the same inner index? Let's say A is 3 by 4. 4. B is 3 by 4. That means this is 3. The inner index does not match. You guys see that? So they don't multiply. But you can see that just by typing it up, right? But what about the actual matrix A and B in 37? Can anyone tell me the dimension of the matrix A? 2 by 3. What about matrix B? How many rows? 3 rows, 1 column. All right. So do they multiply? Yes. See that the indices match. And what we're supposed to get at the end? How many rows and columns? 2 by 1. Right? Is there a 2 by 1? 2 rows, 1 column? There's only one matrix. That's 2 by 1. The first one is 1 by 2. Okay. So, and that's supposed to be the way, but even just like in SAT, I think that some of the questions were designed to see that if you do understand a concept and, do reasoning or something we call qualitative analysis. Qualitative is like you don't calculate, but you just look, right, and observe or think, right, like a mathematician. So anyway, so please learn from 37 the strategy or, the bottom line is remind yourself when the matrix do multiply or when they don't. Okay, so now Cramer's rules. If it's in a test, then you do have to show me what we call the determinants. But I do realize even when you get maybe a two-dimensional system, a system of 2 equations of 2 variables, right? The determinant should be a bit easier to calculate, but people getting sign errors or they confused the Cramer's rules with the matrices. So there are a lot of terms or the superficial stuff between the Cramer's rule and the matrix solution. Could be pretty similar, but they're still 2 different things. But in this case, you're looking at two options, right? So one, it says the system is inconsistent, and the other says the system is dependent. So those are mathematical terms. But if I translate them into like plain language, like a human language, when it comes to solving system equations, what does it mean a system is inconsistent? Is it talking about the system has finite or infinite many solutions, or is it talking about the system has no solution? Or inconsistent means no solution. Then what about dependent system? Do they have solution? Yes, and they have infinite many solutions. Okay, therefore, you just have to tell which one it is, right? But do you remember what we just did back in one of the matrix questions? What will be the, I won't say the quickest, but what will be a smart way using a calculator to tell if a system has infinite solution or no solution? Matrix, right? Type up the augmented matrix, call on the reducible echelon form to look at the last row, right? And I guess that you could do that. You know, I'm not going to type up one matrix, right? Just now, of course, if you're curious about what the Cramer's rule is, you can certainly look it up. I think it's 9.5. But I think that I told you when we go through the chapter 9. So the matrix is what the computer, it's going to work on and is very good at, right? So the Cramer rules, it's fancy, it's not, very efficient for a computer. Right. Okay, anyway, now, oh, wait, I thought that we, give me a second. All right, so let me double check. I think that we did chapter 10. Yeah, all right, so remember that it's on the 16th, right? That was 2 days ago. We did those questions. That's why I should have delete them. So give me a sec. Let's get rid of these questions. So we have them, all right? So down on the 16th, if you watch the recording, so it will be there. There we go. All right, now chapter 11, that's sequence and series. All right, now, I think that the only thing I want to show you with 53 is basically, the calculator. Of course, because I mean, you could do the math yourself, but just showing you another option. Let me get out of this. All right, so clean that up. Now, the way I'm gonna type the sequence in the calculator is treating the n like a variable. Okay, so let's say a sub n is pretty much like a function of n. It's just that n has to be an integer. So I know how to define functions, right? So let me do n plus 2 factorial divided by n to the third. But since the function doesn't care about what variables you call it as an input, right? So if you can find an n and do it that way, you could. But I don't think that the TI is going to take the n as a variable for a function. So you can do x. Just don't put in 1.5 for x, right? Just take integers. Okay, so I do like the fraction structure. All right, so I'm going to put in, instead of n, I'll do x plus 2. right? Don't forget the factorial. Now on the TI-84CE, you can go to alpha window and hit number 9 to get a factorial, right? Otherwise, you have to go math, I think a probability, right? Then number 4. Okay, but either way. Oh, I think that's okay, still there. All right. So what I need is n to the third, right? So let's do x to the third, right? Hit enter, right? So now I'm ready to evaluate it, right? So all I need to do is just feed the number 1, 2, 3, 4 to give me the first 4 terms, right? So let's call on the function y2. Oh shoot. What did I do? Variable function. Right, so y2, so I want the first term, right? So x should be 1 or n should be 1. So it'll be 6. So now the second term, right, 3. Okay, that's good enough, right? So that'll be letter A. I'm not saying you have to do it, but do you see what's happening here? If you think that you're taking a test, or preparing for a test, you are, but I want you guys to be also functioning as a professional. So in the future, you're gonna do something even way more complicated than this, right? You're not gonna be doing things on a paper anymore, right? And you thought that mathematicians nowadays or physicists, they're doing calculations by hand. They are on a computer, as if that they're like a programmer, but they're doing the math, right? They're using AI, they're using those softwares, right? So just by hitting a button to make sure that I do type in something right, this is like a cheap labor, a math assistant, right? So as long as you dictate what to do, and this guy's gonna do it for you, right? And it's guaranteed to be right. Start thinking or functioning like that. That's right. Now, in case you got getting a bit lost, what am I doing? What I did was I typed in the nth term formula, right? You see that the structure is like n plus 2 factorial over n squared, but I know that it's still a function, right? It's a function of n. It's just that the reason why they use n is they don't want you to type in something like radical 3 for n or 1.5, right? So, if you put in an x here, you can put in 1.5, but don't do that since this form is for a sequence. Just feeding the 1, 2, 3, whichever term you want, right, for the x, right? Because like I said, you dictate what you want this guy to do, right? And as long as you know what you're supposed to get, you're fine. Even though that this is obviously a function, right? A real number function. All right, so, but like I said, if this gets confusing, you don't feel like, working it out before the final, you don't have to. Just do it by hand because, I think that's still not going to take you any time to work out the first couple of times. Now, but this one, I'm sure that, you're fine. So I'll just quickly type it up, in a calculator with a summation notation. But I do want to make sure that you guys know, again, different models, right, might be a bit different when it comes to accessing the summation notation. So for CE, the shortcut is alpha window. Then you have number 2 as the summation notation. Or if you do it, the standard way, you're going to go to math. And I think math, right, go down. And you find out the summation notation that way. But either way, you get to specify whatever index you want to use. So I'll still go with x as long as I know that x is going to be an integer, right? So start from 1, ends at 5. So I need to type up, again, the reason why I like CE is I can organize my work, right? To make it look just like what you see on the paper. So I have -1 to the power of I minus 1, -1 to the power of I plus 1, I minus 1. But instead of using I, I'm using x minus 1 over I plus 1 will be x plus 1 factorial. So alpha window 9. Yeah. All right, am I right? -1, I minus 1. There we go, right? Okay, letter A. Okay. Now moving on. Okay, so arithmetic sequence. Find out the a sub n and a sub 20. So for arithmetic sequence, what you really need to get correctly and probably using it to eliminate will be the common difference. And the letter we use is letter D. Okay. So in 57, the common difference is, again, the difference between two terms, right? But the order matters when it comes to subtracting them. It's going to be, let's say, the term a sub 2 minus the term a sub 1. Be 3 minus 10 is -7. Okay. So now, if you want to build the nth term formula, since you already know what the a sub 1 is, right? So recall that a sub n is a sub 1 plus what is that? N minus 1 times the d. So in this case, a sub 1 is 10, n minus 1 times. I guess this is why sometimes, you know, people did get a little error. It's -7. That means later, if you distribute it, it'll be -7. Oops. Hitting the n, right? Now, -7 hits the 1, -1, it will be +7. So please be very careful with the sign change. Simplify it, you get -7n, what is that? Plus 17, right? So that should be good enough for you to get the right answer. So that will be letter D, right? Am I right? That's the only option. 57. Yeah. But of course, you know, you can also try number, well, a sub 20 to see if that will work out. But I'm sure you will. A sub 20 will be -1 to 3. Okay, so is there a better way to figure this out? Now, not necessarily get you the right answer right away, but at least that you should never look at something that's not going to be right no matter what. So here, the common difference is -7. And somehow you see the same number, -7, appears in the nth term formula as if it's a slope, right? You see that if n were to be like some kind of a variable x, this is a linear equation, right? Slope times x plus the y-intercept. So like a, you know, slope-intercept form. But that's not a coincidence. For a arithmetic sequence, once you do the algebra for so many times, you would have noticed that the common difference will be getting to the n, then it becomes the coefficient of n, which means that you could have told after you figured out the common difference, which is -7, that you are supposed to look at only a or d, right? Then unfortunately you have to take a close look at what kind of constants you get, right? And I don't think there are any better way than just figuring it out, right? But yeah, but at least if somehow you decide to look at B and C, that maybe of course you won't realize in a test, right? But you're finding a battle that you're never going to win, right? Looking at B and C. So remind yourself the common difference and where it's supposed to appear in the answer formula. Use that as at least a rule to eliminate. Now 59, the only thing I have to remind you is you probably have to read off the common difference from the recursion formula. And I'll remind you that the recursion formula looks like a sub n equals a sub n minus 1, right, plus the d. Or sometimes they might go with a sub n minus a sub n minus 1, right, equals d. But either way, you see that it's either by adding a common difference to a term to get to the next one, or subtracting two terms, right, to get to a common difference. And therefore, you're looking at a common difference 7. So now you're looking at either C or D, right? They both have the correct common difference. And you know that the reason why they have a different constants is they know that you might have a sign error somewhere, right? Instead of getting 24, you're getting 10, or the other way around. But 59, it's gonna be letter D. Okay, but you figure it out. Okay, so I'm sure that the arithmetic sequence is supposed to be more intuitive, right? But sometimes when it comes to the partial sum, right? The first term partial sum for either the geometric or arithmetic, things gets a little bit out of control. So there are two formulas. One is let's see, a1 plus an, right, times the number of terms, right, divided by 2. That's Gauss's, right, formula. Or n times a1 plus 1/2 n times sequence arithmetic. See, that's a very realistic situation, because I might not also remember what it's going to be. N minus 1. Okay, it's 1/2 n minus 1. So we're thinking n minus 1 and plus 1. So if you're like me, then figure out a way to get this right. So now in this case, I think that maybe the second formula is better, since you know exactly what the number term is, right? So n is 60, a1 is -17. The common difference is -12 minus -17. Notice the sign flip, so it'll be 5. Okay, so then just plug it in, and 61 is going to work out as 7,830. Okay. But if you're such a big fan of Gauss's formula, right, the one in the first line, you do have n 60, a sub 1, negative 70, negative 17. So all you need is a sub 1, a sub n. But you can get yourself a sub n, right? So if you do want to do that, I mean, find what the a sub n is, which is, by the way, a1 plus n minus 1 times the d, right? Since I know what n is, a1 is negative 17 plus 60 minus 1, right, times 5. So you figure out what the a sub n, in this case, a sub 60, right? And plug in, you still get the right answer, okay? But I'll say that for a question like that, it's just to remind you, that was at the beginning of the semester. Even though it was only 6 weeks ago, but you do need to remember a formula for the arithmetic sequence when it comes to a sub n, s sub n, also, you know, the geometric one. All right, so now the nth term for geometric sequence. So now again, common ratio is the one you have to get. All right, and we use little r. So a sub n is in this case a1 times r to the n minus 1. Okay. You remember that this one has a sub n, right? N minus m. So you can find it, you know, on your own. In this case, we have n. Oh, we do want to leave n as is, right? But what about the common ratio? Common ratio is a sub 2 over a sub 1, right? It's always second term divided by the first term, right? Or when it comes to the arithmetic sequence, it's second term minus the first term. So you have negative 1 over 32 over 1/8. Okay, so it will be negative, you know, Pigeon flip, right? You want to go it that way, negative 1/4. Okay, so now we have it, right? So a sub n is a1, that is 1/8 times negative 1/4 to the n minus 1, right? Let's see if there is one exactly matches. There is, right? Letter B. Okay, so that's the straightforward way to get it, right? Or if you feel like that, you know what, let me, you know, just check it to see if it's going to work out. Since all the options, right, if one of them works, then you have to, you know, see if when n equals 1, right, does it return 1/8? If it does, okay, let me check if n equal to 2, does it return negative 1 over 32, right? But that's probably not worth it since you have to do it 4 times, right? And things are not that quick to, you know, work out mentally. So I'll say that maybe at least, you know, figure it out before the final. I mean, doing, you know, do some algebra for arithmetic and geometric. You know, it can work out either 62, right, or 64, or potentially 66. To see how things works out, or how quickly it should be. Now, when it comes to the first n-term partial sum for geometric sequence, the formula is going to be a sub 1, 1 minus r to the nth power over 1 minus r. Okay, so you still need the r. So we find out the r by dividing the a sub 2 by a sub 1. So that'll be negative 10 over negative 5, right? So that'll be 2. Okay, so then you find out what a sub 10 is, right? So a sub 1 is negative 5. 1 minus 2 to the 10th power over 1 minus 2, right? And you figure that out. That's 65 should be negative 5,115. Okay. So for sequence and series problems, it's pretty much just about formulas. Okay. Now, 67. That's probably one of the questions that more students than I expected who got that wrong in the first test, because they probably didn't take it seriously when it comes to the infinite geometric sequence or series. And by the way, so series is just the sum of all terms in a sequence. Okay. So, but I do have to, alert you. There's a reason why they have option like letter D, like does not exist. So when you add up all the terms in a sequence, there are infinite many terms, right? So the more, potentially, the more you add them, the bigger the number is going to get, right? If somehow that the numbers adds up to be infinite, then the sum does not exist, right? How will we understand the infinite sum? But magically, for some sequence, and geometric sequence is one of them, could still work out to have like a finite infinite sum. It's funny to say that. So has a finite sum of all the terms if and only if the common ratio has a absolute value that's less than 1. Okay, so this is super important. The common ratio cannot be greater than 1, and it cannot even be exactly 1. It has to be smaller, but it could be negative because the absolute value, right? Not, I'm not talking about the actual, number for R, right? So let's say R could be negative 0.5. Now, if that works, then you have the infinite sum. So S stands for sum of all terms. That works out as simple as A1 over 1 minus R. Okay. So we have A1, right? So A1 is negative 30. R is, again, A2 over A1. So that'll be negative 6 over negative 30, right? So that'll be 1/5. Right, so you just plug in. So negative 30 over 1 minus 1/5. Now, if you type it in the calculator, then you get it, right? Or you have to do, 4/5. Okay, and somehow it's not going to work on my last number. Say 67, letter B, it'll be negative 75 over 2. Okay, but again, no need to do the mental math. But what you need to remember, and that's why I put a star. All right, so for 67, the infinite sum of a geometric sequence, or the way to put it is the infinite geometric series. It will most likely work, but please be open to a possibility that it may not work. And the way you can tell is whether the absolute value of the common ratio is less than 1. If it is, then you have a nice formula. Otherwise, you don't. Okay. All right, good. 2 more. So 69, Binomial theorem is again one of those topics that it came out of nowhere. So, but again, you'll see it in the Cal, probably in chapter 2 or 3. Now, for the binomial expansion, what you need to remember is the general structure a plus b to the power n, and you're gonna have n plus 1 terms, right? They all go like n c0, right? A to the n, b to the n minus b to the 0, and you don't have to include b to the 0, it's just 1, right? Then n c1, a to the n minus 1, and b to the first power dot 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 to n cn, a to the 0th power, and b to the nth power. Oh, you know what? Let me just add one more term. Then it will be a bit nicer when you see the pattern. So it'll be a to the n minus 2, b to the second power, right? So like I said, it should be n plus 1 terms, right? Starting from 0 all the way to n. And keep an eye on the powers of those two guys. They always have to be added up to the total power n. And of course, sometimes either the so-called a or b are not necessarily just, like x and y by themselves, right? They could have a number, right? Like a 2 multiplying a y, or not to mention you have to take that negative sign into account. And therefore, you will identify in this case, a is x, right? B is negative 2y, n is 6, right? And just to write out a few terms, so y minus x minus 2y to the 6th power, so you get 6c0. X will just be x by itself, right? The 6th power, and there's nothing anymore since b to the 0th power is 1. But if you want, you can put negative 2y to the 0th power. You know that this guy's going to be 1 plus c n 61 x to the 5th power, right? So 6 minus 1, then negative 2y to the 1st power, right? Let me just write out one more. 6c2 x to the 4th, right? Negative 2y to the 2nd power. Dot, dot, dot. Okay. But it'll take time, right? Let's take a look at the options. Well, I'll sit here. Well, you see that getting the first term workout doesn't really help, right? Not to mention the second term, but things get very different from the third term. I mean, you could have, just figured out what the third term is going to be, right? And that's going to bring us to the next question. I'll show you in a second. But how do you find out the third term? I mean, of course, you could remember the pattern and remember, oh, if I start from NC0, the third term is this guy, right? So what does it look like? It has a binomial coefficient, NC2. That means I'm looking at (62), but that's not gonna be the only thing that you're getting a number from, and you're gonna get a number from the negative 2 to the 2nd power, right? Which is 4. So basically, the number in 69 that you should be getting is 60, and that 60 is going to be 62 times negative 2 to the 2nd power, and that has to work out as 60. Okay, so if that's good enough, right, for you to tell which option it is, that would be great. right? All right. So, and like I said, the last question about finding a particular term. All right. So now, if you're looking at the rth term, right? You know, the 10th term. If you remember that a particular term that looks like NCR, right? A to the n minus r and b to the r. But remember that r starts from 0, right? 0, 1, 2, dot, dot, dot. That means the 10th term tells us that r has to be 9. 0 to 9, that has been 10 terms, right? That means we need to look at n is 12, right? 12 C9. So A is going to be n is 12, r is 9, A is x, B is 2y. Therefore, there will be 12 C9 x to the 12 minus 9, then 2y to the 9th power, right? And that has to work out, if you put everything together, 71, it will be 112,640 x to the 3rd, y to the 9th. Okay, and please notice that maybe just by tracking the power of x or y, then you probably don't even have to work out the number just to see that one of the options, or maybe that's the only option that has to cover the power of the y. You see that? The 10th term, the 9th power, right?